Welcome to Engineering Mechanics tutorial. Today, we're going to discuss about part 3 of chapter 2, Resultant of Force Systems. The topics for this session are couples and their moments, reduction of force into a force and a couple, equivalent force couple systems. So first, what is a couple? A couple refers to two or more parallel forces that are equal in magnitude, opposite in sense, and do not share a line of action, also called as force couple. So this is an example illustration of a couple with two parallel forces. So first, we need to get the resultant forces. First given is 45 Newton going down, 90 Newton going up, 135 Newton going up, and 180 Newton going down. So by getting that resultant, we will get an answer of 0. Take note that although the resultant is 0, their moment sum is constant and independent of the moment center, meaning to say that even the resultant is 0, the moment force has still its value. In getting the summation in moments at A, 45 Newton is going clockwise. That will leads us to a positive 45 multiply with 0.61 meter. Next is 90 Newton that is going counterclockwise, that gives us negative 90 multiplied with 1.52. And if you're asking how does 1.52 get, just simply get the summation of 0.61 meter and 0.91 meter. Next is 135 Newton that is also going counterclockwise, multiplied with the summation of 0.61 meter, 0.91 meter, and 0.3 meter, with total of 1.82. Next is 180 Newton that is going clockwise, multiplied with the summation of 0.61 meter, 0.91 meter, 0.3 meter, and 0.61 meter, with a total of 2.43, and that will give us the summation of moments of A with a total of 82.35 Newton meter. In getting the summation of moments of B, 90 Newton is going counterclockwise. That will give us negative 90 multiplied with 0.91 meter. Next is 135 Newton, also going counterclockwise, multiplied with 1.21 meter. Next is 180 Newton going clockwise. That will give us 180 multiplied with the summation of 0.91, 0.3, and 0.61 meter, with a total of 1.82 meter. So the summation of moments at B in total is 82.35 Newton meter. Same with the summation of moments at A. In getting the summation of moments at C, 45 Newton is going counterclockwise. That will give us negative 45 multiply with 0.91 meter. Next would be 135 Newton, also going counterclockwise. That will give us negative 135 multiply with 0.3 meter. Next is 180 Newton going clockwise. That will give us positive 180 multiply with the summation of 0.3 and 0.61 meter. So all in all, it will give us the summation of moments at C with a total of 82.35 Newton meter. And lastly, by getting the summation of moments at D, 45 Newton is going counterclockwise. That will give us negative 45 multiply with a summation of 0.91 meter and 0.3 meter, that is 1.21. Next is point C with 90 Newton going clockwise, which gives us positive 90 multiplied with the distance 0.3 meter. And next is 180 Newton going clockwise as well, multiplied with 0.61 meter. All in all, that will give us the summation of moments at D with a total of 82.35 Newton meter. The reduction of force into a force and couple. So this is replacing a force acting at a given point into an equal force acting through some other points. Let a known force F act as A be reduced to a force and a couple. So first thing you must consider in reduction of force would be adding the two collinear forces F double prime and F prime, which are equal and parallel to force F at point B. So as you can see here in this first diagram, F prime and F double prime is collinear to each other and they are parallel to force F. Next is to rewrite F double prime, which is equal to F multiplied with D, which is a couple, and only F prime is left, which acts at B. As you can see here in the next diagram, only the left force is F prime. And finally, redraw the whole figure. So the final figure would be like this. Point A is here, the distance D, and the F prime that is shown here. So given problem number 203, a force system consists of a clockwise couple of 650 Newton meter plus a 1000 Newton force directed up to the right through the origin of X and Y axis at angle 30 degrees. Replace the given system by an equivalent single force and compute the intercept of its line of action with the X and Y axis. So this is the illustration for the whole problem. This is the F double prime, the F prime, the distance D, the resultant force F, and the 30 degrees angle. So the solution in getting first the given C, which is equal to 650 Newton meter. Next is F, which is equal to 1000 Newton. And lastly, the angle in X, which is equal to 30 degrees. The required that is needed to find is the F prime, the X component, and the Y component. In solving for D, we are going to use the formula C is equal to F times D. By simply substituting the given, 650 Newton meter is equal to 1000 Newton multiplied by D. Revising this equation, we will have D is equal to 650 Newton meter divided by 1000 Newton, and we will get the D, which is 0.65 meter. Now, in solving for X component and Y component, we are first getting the f of X and f of Y. So f of X is equal to f cosine theta and f of Y, which is equal to f sine theta. By substituting, f of X is equal to f cosine 30, f of X is equal to 1000 Newton multiplied with cosine 30. So we will get 866.02 Newton for f of X, and for f of Y, 1000 multiplied with 0.5, and we will get a total of 500 Newton for f of Y. Now, we will use the principle SOHCAHTOA. So, cosine theta is equal to adjacent over hypotenuse. Since the illustration of the angle is here, it's like this. The angle 30 degrees is in this side and not in this side. Therefore, we will use this formula. This will be the equation that we are going to use. The reciprocal functions. Since this is the right triangle that is in the illustration, we will be using hypotenuse over adjacent. And by substituting 0.5 cosine 30 is equal to 0.5 meter all over y component. Revising this, we will get y component is equal to 0.5 divided by cosine 30 degrees. And we will get the y component 0.75 meter. Next, in getting the x component, we will be using the TOA in SOHCAHTOA, which is tangent theta is equal to opposite all over adjacent. By substituting the IY or the y-intercept, tangent 30 degrees is equal to 0.75 meter divided by x component. Revising this equation, we will get x component is equal to 0.75 meter all over tangent 30. And we will get a total for x component of 1.30 meter. Next topic will be the equivalent force coupled systems. Every set of forces and moments has an equivalent force coupled system, which is a single force and pure moment acting at a single point that is statistically equivalent to the original set of force and moments. So this is an example problem, number 204. From the figure shown, find the equivalent resultant force and coupled moment acting at A and also the equivalent single force along the beam AB. So this is the example illustration for the problem. Find first the summation of f of x and the summation of f of y. So we must get first the f of x and f of y in this area. So f of x is equal to 10. F of x is equal to 10 cosine 60 or 10 sine 30, which is equal to 5 pounds. For f of y is equal to 10 sine 60 or 10 cosine 30, which is equal to 8.66 pounds. By getting the summation of f of x, which is 5 pound plus 6 pound in this area, we will get 11 pounds. And in getting the summation of f of y is equal to negative 8.66 since the arrow is going down, minus 5 pound, which gives us a total of negative 13.66 pounds. Next, we are going to take the summation of moments at A. Summation of moments at A is equal to 8.66. Since f of x is not applicable, 8.66 will be the only one that is applicable to rotate or turn, multiplied with distance 6 plus 5 multiplied with 18 minus 6 multiplied with 15. That will give us 51.96 inch-pound couple moment. Next, we are going to get the equivalent resultant force. F is equal to square root of 11 pounds square plus 13.66 square. That will give us 17.54 pounds. The location of F along beam AB, we are going to use this formula. Summation of moments at A is equal to summation of f of y multiplied with d. Revising this formula, we will get d is equal to summation of moments at A all over summation of f of y. By substituting the given answers earlier, 51.96 inch-pound all over 13.66 pound, and we will get a total of 3.804 inch distance of F from point A. By getting the angle, we will use the formula angle is equal to cotangent summation of f of y all over summation of f of x. By substituting the answers earlier, we will get cotangent 13.66 all over 11, and we will get an answer of 51.66 degrees, the angle of inclination of F with respect to X. So this is the illustration for the answer. This is the f of x, which has 5 pounds, the degree, which is 51.16 degrees, and the f of y, which is 13.66 pounds. And it is turning clockwise. So that's the end of this session. Thank you for watching.